So in this problem, we're asked to draw the axial force diagram for the cable. So we're going to start off by drawing our free body diagram. So we're going to start by just drawing our cable, and we're going to start putting in the forces that we have. So we do have this upward force, F. We're going to call it FA because we're going to label the points. So the top will be A. The point where the two diagonal forces are acting is going to be B. The third downward force of 2 kilonewtons, where that's at, is going to be C. And then D will be at the 3 kilonewton force. So we have an upward force, force A, acting on this cable. And then we have this force here. These are 4 kilonewtons of force acting on a diagonal. And we're given the angle for those is 60 degrees. And that's the same on both sides. And that means that this angle here is going to be 30. And that's what I'm going to use for the equilibrium equations, because I just think it's a little bit easier when we use it like this. I like that triangle set up like that. And then we also have this downward force of 2 kilonewtons and our last downward force of 3 kilonewtons. So now we're going to do our equilibrium equation for the cable. So net forces in the y direction, we have a bunch here. We have this downward force of -2. We have this other force downward of 3. We have the upward force of A, so that's positive. And then we also have upward forces of the y component of these 4 kilonewton forces. So these are just like triangles like this, with this angle right here being 30. And so the y component of this triangle is going to be sine of 30. So we're multiplying the force by sine 30 to get the y component. And then we have that twice. We have it on both sides. So we're going to be adding that twice. And that is equal to 0. And then you solve for this, and you end up getting the result that force A is equal to 1 kilonewton. So now that we solve for our different values along the cable, we're going to redraw our free body diagram, and we're going to draw it horizontally since we're looking for the axial forces in the axial force diagram. So we first have our 1 kilonewton force acting to the left, and then 3 meters from that, we have our 4 kilonewton forces acting diagonally. And then we want to remember that the angle in here is 60 degrees. And that's the same for both forces in this case. And then from there we have 2 meters apart. We have our force acting this way. This is our 2 kilonewton force. And then finally, another 2 meters away, we have our 3 kilonewton force acting. So this is our free body diagram, and this is what we're going to use to draw the axial force diagram. So we're going to start by drawing our axes. Like this. And then force is going to be on the y-axis, and that's going to be in kilonewtons. And then on our x-axis, that's going to be the location at which the force is acting on the cable. So first we have our 1 kilonewton force acting to the left. And any force acting to the left is going to be a jump up. So we're going to start right here at 1 kilonewton, and that's going to be constant because we don't have any other forces acting until we get to these 4 kilonewton forces. So it's just going to be this straight line until we get to these 4 kilonewton forces. And then from these 4 kilonewton forces acting on the diagonal, we only want their horizontal component because that's what we're looking for this diagram. So essentially what we do there, it would just be the calculation we do 4 kilonewtons times cosine of 60, and that will give us the horizontal or x component in this case. And that's 2. So when you add 2 together for each, you're going to end up getting 4 kilonewtons acting horizontally between the two 4 kilonewton forces. So that would be, that's also acting to the left, that'd be a jump up of 4 kilonewtons. So that'd bring us up to 5 kilonewtons, like that. And then same thing, we don't have any other forces acting until we go over 2 meters, so it's going to be a straight line. And then we have 2 kilonewtons acting to the right. Acting to the right is going to be a jump down, so we go down 2, which brings us to 3 kilonewtons. And then we don't have any more forces acting again until the 3 kilonewton force. And once again, that's acting to the right. Acting to the right is going to be a jump down. So we're going to go down, and we're going to end at 0, which this is a good check. We want to end at 0. It means that we did it right, and this is our axial force diagram.